let me snip it in. So you sent me this picture, and that's all the
Okay,
work we just did for that. So if you're referring to something else,
yeah,
let me know.
that's it. Sorry. So, okay, so when you have that, that's for an exponential table graph thing.
Yes.
I'm so with that, so I guess with the other ones where they're linear, correct?
Yes. And we were using MX plus B for the most part on those.
So is there anything else I can do with that, or is that just kind of it?
So like they could ask you, like part A was to write the equation.
Mm-hmm.
So we did that check. Part B was usually like verify that f of 3 is 27.
Mm-hmm.
So you're just putting 3 in for n.
Yeah.
F of 3 means 3 to the power of 3, which is 3 times 3 times 3, which is 27. And then the next one was like, what is, like, let's say it's 243 equals f of n. But this is probably out of scope, where you would have to actually like solve for it. And that's it. So you're either putting a number in for n, probably just putting a number in for n for these, because it's beyond what you sort of know for this course.
Mm-hmm. Okay. All right. So I guess, all right. Yeah. I mean, I never really went over that too much in class, so I'm just assuming that it's not the biggest thing, but for the most part, I'd just be getting like, would saying rate of change work in this scenario?
No, because it's okay, because rate of change is exclusively used for slope. Slope means rate of change.
Okay. So would I just say the numbers increase in
Exponentially. They increase exponentially if you're asked to do that.
All right. Okay.
So the difference is that
the difference end with it being the 9.
Say that one more time. I'm sorry.
So would I just end with writing it as like Fn equals 3n?
Yes.
And then that's just probably it. I wouldn't get the other like
There's,
A question.
I don't know. Maybe you could get a part B to verify something. But the main difference you should notice here is that you're multiplying instead of adding. In the linear ones, you're always adding or subtracting. Here you're multiplying.
Okay.
Now you did get a problem. We should do this. We should do one more of these. You did get a problem on one of your sheets, and I'll show it here. And it was like 1 was 2, 2 was 1, 3 was 1/2, and 4 was 1/4.
Mm-hmm.
And so how are you going from?
You're dividing by 1/2.
So you gotta be careful here. You're dividing by 2 or multiplying by 1/2. So if you divide by 2, that is the same as multiplying by 1/2.
Okay, that's true actually.
And so in terms of like what goes in parentheses here, it's the thing that you're multiplying by.
So when it's moving exponentially, it's always going to be by multiplication. Like
yes. And that's the main difference. Linear means it adds up to the same it adds up each time by the same amount.
Okay. All right, thank you. All right, I guess that kind of clears that up for me.
Okay, good. Okay, so let's look at this. You said, hey, Matthew, B and C, I don't remember doing in class. So let's do those because inevitably that's the thing that'll be on the quiz or test. It's the thing that you didn't remember seeing. We never did that.
We didn't do that.
Yeah, okay. So the key word here is in a linear pair, One angle measures 10x plus 40 degrees and another measures 3x plus 10 degrees. So a linear pair, by definition, that's probably one of your definitions, it's 180 degrees. Graphically, it's the two angles. It's like, consider this angle 1 and this is angle 2. The two angles add up to 180. That's what a linear pair means. Linear pair means line's got 180 degrees.
Okay, linear. So then,
So you take these two
linear is
expressions.
so
Go ahead.
linear is always a 180-degree line.
Yes.
180-degree line.
So in your problem, and you don't have to draw this picture, but it could help. You have two angles
Mhm.
and they add up to 180 degrees.
All right, and
So,
then
so you literally write 10x plus 40, the two expressions,
10x plus 40
equals 180 degrees.
Okay, 10x plus 40 plus 3x plus 10 equals 180. And then that would give you 13x plus 50 equals 180.
Good. Keep going.
15x equals 130. X equals 10.
Good.
So then, is that x representing the unknown angle?
No, x represents x. So look back at the question. I'll scroll up here. It says, what is the value of x? X is 10. We've got x. But it goes on to say, what is the measure of each angle? So in many problems in geometry, you both solve for x and you substitute it back in to find the missing angle or side or something else. Mostly angles and sides in this course.
Okay.
So you have to substitute that back in.
Would I insert the number?
Yes. So it's like 10 times 10 plus 40 and 3 times 10 plus 10.
10 times 10 plus 40. And then once you go through that, it would be like 140 and 40.
Yes.
And then
that's it. That's where it says, what is the measure of each angle? Measure literally means the value of the angle.
okay, and then I guess that would be your final answer, correct?
Yes, you're done with that problem.
Okay, 140 and 40. So then, okay. So
try to express yourself here, because I think this is important, because
yeah.
What do you think is bothering you about this?
I guess like the only part that's bothering me really is just knowing like how many degrees would like a linear pair be, or whatever the other.
Yeah, so you got to remember some stuff.
Yeah.
And we're going to see that in the next one here. So in this problem, the angles are complementary. And that doesn't mean that they, they sort of like are complements of each other in terms of like they work well. It's that they add up to 90 degrees. Complementary means 90 degrees.
Okay.
Supplementary is like a linear pair. It's 180, but complementary is 90.
Okay. So if there's two complementary angles, would that technically make 180?
No, complementary angles make, so they're saying that the two angles together are complementary. But so they make a 90 degree.
Oh, okay.
5x plus 20, 3 halves x plus 5. It's a good question, because it logically No, you might think, okay, well, if they're both complementary, they're both 90, but no, they just add up to
Mhm.
290. So you have to write this expression. And actually, this is a good one for us to, after we get to this part here,
Mhm.
I want you, and you can probably just do it verbally. I want you to tell me the rule for this. So a T chart looks like this. See how
Yeah.
there's a T? On the left is a statement. On the
Mhm.
right is the reason.
All right. 2 and 1, I guess. All right. Statement, reason. So I guess my teacher says like the first part's just given
Okay,
as like for first reason.
that's fine. Yeah, and that you're going to do that in your proofs coming up.
And then I guess my next step would be simplifying the
So
equality or
you could add the 5 and the 20 together.
mhm.
I would
But would you
probably
rather to subtract?
well, you really should combine those. Like you're supposed to do it one step at a time. So this is okay. You could sit here and say simplify.
Okay. And then would I write just simplify or would I write simplify like terms?
Whatever your instructor has indicated.
Okay. I guess I'll just say simplify or slash combine like terms or something like that.
It's good to be more verbose, which is what you just said, where to add more words in.
Mm-hmm. Simplify like terms. So then that would just be adding the non-x's together. 5x plus 25 equals 180. So then I guess
So
I
what would
would
you do from here? And there's a lot of right answers for this.
I guess I do substitution
There's no substitution
property
because
of
you're not substituting. You're either going to subtract 25
yeah.
or you're
I
gonna
mean like I'd subtract 25 and put it into the 180.
okay. So that's this yeah subtraction property. You said substitution. Maybe you meant subtraction.
Yeah, I think that's what I meant. Um substitution property of equality. So then substitution property of equality. And then
So we have 3 halves x plus 5x equals 155.
155. And then once you have that, I guess would
So
you just say simplify because you'd be adding oh no, I'd
if you,
multiply it all by 2.
yeah, that would be you could either add them together and you could do that off to the side. You'd be like, all right, it's 3 halves plus 10 over 2 because that's 5, 13 over 2. Or you can multiply everything by 2.
That's probably the smart way to do it.
Yeah, whatever you're comfortable with, but that's the multiplication property of equality.
All right, multiplication property of equality.
And again, like you're only supposed to show the end result of the step. You're not supposed to show the intermediate, which means you may have to work things out off to the side.
Uh-huh. Okay.
They may not be super picky about that, but it is a point of, something to consider.
Yeah, I'll just do that so it shows my work and still keeps the answers neat. And then okay, so you'll have 3x plus 10x equals 310. Would I just say simplify like terms?
Yeah, simplify like terms.
Simplify like terms.
Oh, you know what? I messed up real bad here. This is actually equal to 90. So this is going to change a lot of things because I
Oh,
was like,
no.
why isn't this working?
Yeah, I was gonna say it's like wow, it's like perfect.
Yeah. So
Alright.
sometimes you get tired and this happens. So this is
Yeah.
because it's supposed to be 130 because I'm like, that doesn't work. So now 130. So what is the last step?
65, 130. And I guess if anything, it makes it more easy for us. 130, and then you would divide like terms?
No,
No,
division property of equality.
division property. Division property of
Equality.
equality. All right. Maybe I can just write like an abbreviation key chart or something. So I don't.
Check with your instructor before doing that.
Yeah. Okay, so
that's it. So we chose to do it in a T chart. You don't have to do it in a T chart. We just chose to do that.
yeah, just
Let's go back and look at the problem though. Are we done? What is the value of X?
the value of X
It's
10.
10. What are the measures of the other angles? Are we done with that?
So we have to insert
Substitute or insert the value of X.
10 plus 5 plus 5 times 10 plus 20, 15 plus 5 plus 50 plus 20. That's 20, 40, 90. Okay. Oh yeah. Okay. You got. So you write them as two different things because
Yes,
two different
yes,
things.
because they're different angles. They're not the same. They could be the same, but they're not
Wrong.
in this problem.
Right.
Now, very important is to put the degree symbol when you're doing angles.
Okay.
Very,
Yeah,
very
I guess
important
that-
because it's like 20 what? That's what my algebra 1 teacher from a million years ago said. 20 what? Elephants? Like, no, degrees. But he's like, well, you got to write it down. Like, okay.
I guess. Yeah. All right. I guess that guy has a good point.
Sometimes it sticks, some things stick with you, and you know, you just got to be careful that it's good stuff. So that takes care of B and C. Linear pairs, 180 degrees. Supplementary angles, 180 degrees. Complementary angles are 90 degrees. There's nothing else you will see in this problem. And you actually wrote that on the top right, complementary and supplementary, 90 and 180.
Yeah, I just wrote those because I was like, I gotta remember that.
Okay. Now there's a lot of words on the definitions vocabulary check. Are there any of those that you need me to clarify for you?
Okay, I actually have like a paper kind of.
Or we can move on to something else, of course.
I think I'd like to work a little bit again on what we did yesterday.
Okay.
Just like not goes crazy in depth with it, just because we already sort of did, and then just more of a review thing. But there is a sheet I have. I can send a picture to you.
Yep.
Yeah,
Keep sending stuff.
For today.
Otherwise, I'll just start snipping in questions for us to do.
So everything. All right, yeah, it's not blurry. I thought I was like, oh, I moved my camera right when I took the picture. Everything with like a minus symbol next to it is wrong in this picture. I don't know. I think this is just mostly. I need to just memorize this stuff. It's like not really a concept thing, but I wouldn't mind really like having maybe like a mini explanation for some of them, just because the
Okay.
teaching.
Which ones are you thinking?
Maybe like collinear, complementary angles, congruent, and then I think counterexamples like something that's showing it's like the same thing, but you can do it a different way. Would that make sense?
Let me, so we got a lot of things here. Yeah, let me talk about counterexamples first. Okay.
All right.
Okay, so for example, a number, sorry, let me think of one here. Let's do it. So the median is always the altitude. So here's a triangle, very carefully chosen,
Mhm.
where the median is the altitude.
Oh, so then you could just draw a triangle with like a 90-degree angle.
You could draw basically any other triangle besides the one I gave you, where there's the altitude and there's the median.
Mhm.
So the counterexample, this is the counterexample, but you got to come up with one.
Okay. All right, so it's basically like, oh, here's the same thing, but not. Sorry, I can't think of a way to like word it properly. There's
You're
like,
just trying to find one exception to the rule.
okay. All right, yeah, I guess that's in a way what I was trying to say.
So like your parents say, Zach, you always come home from school late. And you're like,
Uh,
no. On Monday, I was here on time.
mhm.
One counterexample.
Okay. All right. I
Sorry,
like that.
that was kind of negative, but like you just got to find one instance where what is being said is false.
Yeah.
And sometimes it's hard. I mean, that's what proofs are. They're hard to figure out sometimes.
Okay. All right. Thank you. That makes a lot more sense than the previous ways explained.
Yeah, and I chose this median and altitude because we are going to have to look at some of those at some point if we got time. Now you have a match the definition to terms.
Uh-huh.
Do you want us to go through those?
Um, yes and no. I mean, it would be helpful, but I also want to review the things we covered yesterday a little bit too. Just because
Okay.
I know like for sure those will be on the test, and then I'm not sure like which one of these are going to be on the test or not.
All right, so here we go. Here's a problem I found. They got a new triangle here. A is 0, 1, B is 3 minus 7, and C is 5, 1. Okay, so let me graph this. So there's a point, there's A, 3, 1, 2, 3, 4, 5, 6, 7. There's B, and C is right here. So here's your triangle. A, B, C.
So then A, B,
0, comma, minus 1,
C.
3, comma, minus 7, and C is 5, comma, 1.
And then given ABC where A is from the median is from vertex C to the midpoint. So that means that's in the middle.
Yeah, so it's some line like this is your midpoint. Or your median. Your median goes to the midpoint at some line.
And that makes two lines that are the same.
These are congruent. Yes.
Yeah, right, that's the proper word for it. So congruent basically means like the same.
Yes.
Okay.
Okay, so we want the equation of this line, which means we've got to first find the midpoint. So I'd like you to calculate the midpoint between those two.
Is that where it's like x1 plus x2 over 2 and y1
Yes.
plus y2 over 2? All right.
Yes.
And I'd be using points A and B, of course, right?
Yes. Yes. And that's why the picture helps to clarify if it's unclear.
Yeah,
You know,
I think it just always
like-
draw a triangle. It's worth it.
Yeah, if you've got the time, I would do it for every problem.
Minus 1, minus 7, 2. 3. Okay, so I got 3 halves and minus 4.
Yeah, it doesn't work out great, but that's okay. I mean, sometimes that happens.
Yeah.
Okay, now to write the equation of a line, we used this a lot yesterday. Y minus y1 equals your slope, x minus x1. What do you need for this? You need a point and a slope.
Yeah, so I can just insert 3, -7 is x1 and y1, correct? I mean, not 3, -7, 3/2 and negative.
Yeah.
So for slope, y2 minus y1 over x2 minus x1. So would I once again just use b and
You
is
need
it
you need the slope of a and
b?
no, I'm sorry. No. You need the slope of m to c.
Uh-huh.
That's why you needed this midpoint.
So I'm treating
So you're using the midpoint and c for your slope, and it doesn't work out very nicely,
but it
truthfully.
gets it done.
Yeah,
So
and I'll help with that. So it's -4 minus 1 in your numerator.
so then
And then your denominator is 3/2 minus 5.
3/2 minus 5.
Yeah, and I doubt you get anything like this in the test, but
It's
so
just
you got -5 over this. So this is 3/2 minus 10/2.
minus 7/2.
Yeah.
And then
And then
for
you can multiply by the reciprocal.
mhm,
So that clears out the bottom. The top is really -5/1 times 2 over -7. So it's -10 over -7 or 10 over 7.
10 over 7. So then,
That's your slope.
okay.
And we're used to
So
getting
then,
nice slope values. Just unfortunately,
yeah.
this didn't give us that. So going back to this equation, you can use either point M or C, but we need the slope, which we have now, 10 over 7. I guess I would use point C.
Yeah, it's just easier, no fractions.
Yeah, but you still got one there.
10, 7, x minus 5. So then, I'm done with that part, and then if it asks like, find, what's like another question that would kind of be asked based off getting that final part of the equation?
Really, you're done there. I mean, that's it. But it does. You're for whatever reason, they go on to ask if these other points are collinear,
Uh-huh.
which is really weird.
And then collinear means that they're the same, or
Yeah. Collinear means they're on the same line.
oh, okay. So I mean, I mean, are they? It's I don't know.
Oh, this is a bad example. Let's just say, like, because I don't want us to evaluate this. Let's say you came up with the following formula: y minus 1 equals -2x plus 3. Okay, let's just say you did all your work and you got this formula. Is that okay?
Yeah.
And then we want to know, is the point 0, 2 collinear?
When
So what you do is, this is x and this is y. You put 0 in for x
okay.
and 2 in for y.
And then that would just be 2 minus 1 equals -2 parentheses 0 plus 3.
Yes. And you're looking to see if they're the same.
And then 1 equals -6. So they are not collinear.
They're not collinear. That's right. They would be if they equal the same value. Let me see if I can find one that does that. How about the point -1, -2?
And I treat the -1 as x and -2 as y, correct?
Yeah, it's always x and then y.
Okay. I didn't know if it was like based off the already like collinear thing or non-collinear. Um, so then -3 equals +6. Or
Are you putting them into, I'm sorry, I did this backwards. I apologize. I gave you the wrong point. It's -2 -1. Sorry.
oh, okay.
I was like, because you said something that isn't true. So,
Yeah.
um,
Okay, yeah, so -1 -1 -2 equals -2 parentheses -2 plus 3. That'd be 1 -2. So yeah, they would be collinear because they're both -2.
yes,
Okay. All right, yeah, that makes a lot more sense actually. And so when they do a problem like that, they're just gonna give me the x and the y usually, correct?
yes.
Okay. All right, cool. That's not too tricky. Um, okay, yeah, so then I guess back to more on stuff kind of from yesterday. So there's linear for like a bar graph table thing means it's getting added or subtracted. And then the perpendicular bisector is going through the middle of a line, creating two collinear lines, but that's also 90 degrees, but it doesn't have to go through the vertex.
That's right.
And then the altitude is going creating a 90-degree angle, but it doesn't split them up evenly.
That's right.
And then it's coming from is it the vertex?
Yeah. So this is an altitude. This is a median.
And a median's just splitting it into two, correct?
That's right. And then the perpendicular bisector, if we kind of draw the same type of graph, it's a line that goes right through it goes through
Middle.
the same point as the median. I mean, that's maybe,
And the median's the only one that's not 90 degrees.
that's true. Yep.
And then the perpendicular bisector is the only one that's not going through the vertex.
Yes. Yes.
Okay. And then they're all essentially solved.
They're all equations of a line.
Yeah. And so that means they all get solved to like x1 plus x2 over 2 and y2 plus y2 over 2. Correct.
Yeah.
All right. So they all get solved the same way. They're just different lines inside a triangle.
Okay. So I think it's clear. We can do another writing the equation if you would like. We could also move on to some other stuff.
Yeah, I mean, I
Actually,
think,
we do need to do a vertical angles problem because that I see something here that's different.
all right.
So I'm
Yeah,
looking at
let's do it.
4A. Now we're kind of going backwards a little bit, but we have not covered this yet. So we talked about supplementary, complementary, and linear pairs. Now we're going to talk about vertical angles. So vertical angles are congruent. So there's kind of two things in geometry that you see all the time. You either set equal or they add up to something. So the add up to something is like the complementary, supplementary, linear pair, triangles. The set equals when they're congruent, or in this case, vertical angles.
Okay. So set equal, congruent, and they're vertical. And then they add up to something. So are we solving to figure out what they add up to?
They're equal. You're setting them equal. The vertical angles are congruent, so you set them equal. 4/4 x plus 2 equals 2 times x minus 2.
Okay. Okay, all right. Yeah, maybe, yeah, I guess I'll just ask questions as we go along with the problem, maybe.
Okay, so we're just going to solve here. I would distribute the 2 on the right. So it's 4/3 x plus 2 equals 2x minus 4. Is that okay?
Yes.
Okay, now I would get rid of the fraction.
Yeah, I think I'd do that too.
Okay, so what do you multiply everything by to get rid of the fraction?
By 3.
3. So everything. Everything means everything. Doesn't mean you get to miss one and get the problem wrong. It's everything. 6x minus 12.
And then you would subtract subtract 6 and 6x.
Okay, yeah, subtract 6, subtract 6x. I like it. Minus 2x equals minus 18.
X equals 9.
Yeah,
So is that it?
that's it. But does it want x or does it want the measure of angles?
Mm,
What is it asking for? Does
the
it ask
measure
for x?
is-
No, it says what are the measures of the angles? So you have to put that x value back into the equations.
So then we got what was it? Positive 9.
Yes, x is 9.
All right, 4/3 times 9 plus 2, that's 14, and then the other one's also 14. So does that prove that they are congruent angles that are vertical?
Yes. If
And
it's
then,
the same value, yes.
all right, and then you wrote are congruent under vertical angles.
Yes, vertical angles are congruent. That means they're the same.
Okay, so vertical angles are always congruent.
Yes.
Okay. Okay, cool. I didn't know that until right now. Okay, so problems like that are just kind of like algebra in a sense, right?
Exactly. But you got to know what to do. You got to know, are you saying them equal? Are they adding up to 90? Are they adding up to 180? And it depends on what they are. Complementary is 90. Supplementary is 180. Linear pairs are 180. Triangles are 180. Vertical angles are congruent.
All right. Okay, cool. So then, all right, yeah, I guess definitely get the complementary and just all those memorized for their measurements.
So why don't we look at the page with the matching of the vocabulary? And probably what I'll do is I'll probably just write the word next to it rather than try to match it. So let me just grab a couple snips of this. All right, so let's just go through this. So no dimension, a place in space, that is a point. If it extends in one direction, that is a ray. If it extends in two directions, that's a line. The part of a line that has two endpoints, that's a line segment. Any questions on that so far?
No, I don't think so.
Points on the same line are considered collinear. There might be two L's in that. I can't remember.
It's all right.
There are two L's. Two rays that share a common endpoint. That one's kind of unclear. It's referring to this, and that's an angle.
Mm-hmm. So two rays that share a common endpoint. So that just means just literally an angle.
Yes.
All right. And then
Divide two equal parts in half. That's congruent. Sorry, my screen is just
oh, it's all good.
glitching
Okay,
here.
so for into two equal parts.
That's congruent because they're equal. We just said that they're
So
equal.
then saying something like bisector would be incorrect.
Yes. No, that is correct. Because it does exactly what you just said. It cuts it into two equal parts.
So would both of those technically work, right?
Yeah, I would accept both. You ever watch Jeopardy? And when Alex Trebek was alive, he'd say, "Well, we got to go to the judges," and
Oh yeah.
they give him the thumbs up. They're like, "All right,"
All right, sweet.
they're like, "Yeah, we didn't think of that one," and
Yeah, it's always funny when that happens.
yeah.
Yeah, guess
Two angles side by side on the same line. So that picture is like this is referring to H. It's the linear pair.
linear pair. Two angles side by side. And that
I,
would be like
I don't think that's a really good. I don't think it's a very good definition, but
it explains it, but not like greatly.
yeah. So now a flat surface that extends infinitely in all directions is called a plane.
And that's something that you like literally can't draw just because it's
Yes.
like trying to like map the ends of space or something.
Yeah, it goes on forever.
Okay. And then I guess the segment that joins two non-consecutive vertices, would that be
So that's a diagonal.
a diagonal? And would I
Yeah.
write just diagonal or diagonal line or?
Just diagonal is probably okay for that.
All right. And I guess those are kind of like all the main things that like you should definitely know for.
Yeah, let me really quickly get the other ones. We'll go through those real quick.
All right, thank you.
Some of them you already know because we've talked about them at length tonight. Okay, the sum of two angles equals 90. Those are complementary.
Complementary. And then an example of something that fits your definition but isn't. That's a co-example.
Counterexample.
Right. Shoot.
Counterexample. Sum of two angles is supplementary.
Supplementary. An example of something that fits your definition. Another example.
Okay, let's get through the other ones here. L because you need these other ones, right? LM.
Yeah.
Okay. So M is convex. It's the convex polygon. This is a regular polygon. Just gonna have to give these to you. Parallel lines.
And parallel lines mean that they're the same angle and they're going like they're next to each other and they're always going at like the same
Slope, yes.
slope. Okay. Or when two lines intersect, so vertical. So is that just two lines like when they intersect that create two pairs? That's just like a
Those
intersection.
are vertical angles. because it says
Okay.
the non-adjacent angles, so that's vertical angles.
Vertical angles. All right, and then.
Oh, you know what? So they did want bisect for G because
Uh-huh.
congruent is L.
Oh, okay. For L, having exactly the same shape and size.
Yes.
All right. Um. Shoot, that's all of them, right?
That's everything. Yeah. So if you got time, make some note cards or just look at them. Look at the ones you don't know. Don't review the ones you do know. It
Yeah.
doesn't help you, even though it makes you feel good.
Makes you feel good, but doesn't help.
Yeah, it does not help. So go through the ones you don't. All right, Zach, I'll send out the notes here in the next couple minutes, and that's it. Thanks for letting me help you. And as always, when you need help, I'll be here. Have a great
Yeah,
night.
of course. All right. Yeah. Thank
Good
you
luck
so
on your
much.
exam.
Yeah. Thank you. See ya.
Goodbye.